Hello everyone, welcome to this online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So last lecture we discussed about the resistance welding and we saw how it is important, how it is generated over there and what are the advantages, disadvantages. In detail we have already discussed. Today we are going to take gas welding. So we'll see what gas welding is, how it is generated over there, and how it is being on whatever what material that we are going to weld through this one means what are its application. We'll see advantages of this process, what are the advantages, and then we'll see disadvantages and what are the major application of this process. So one by one, these four things we are going to discuss in today's lecture. So we'll start with the gas welding. So what is the gas welding? We during the introduction itself, we have discussed what is the meaning of gas welding. In all the welding processes so far we have discussed, the important thing is what is the source of the heat, means how heat is being generated during the process for the welding. Okay, so here the main source of the heat is the exothermic reaction between the fuel that we are using. Generally we use in gas welding acetylene C2H2 and oxygen. So these two will have combustion, and because of that exothermic reaction, because of the combustion, heat will be produced. That heat is used to melt the material wherever we have to do the welding. So this welding of process also comes under the category of fusion welding. Fusion welding means material will be melted, material state will change from one state to another, and then of course it will solidify and welding will be there, or the parts will be combined together. So this gas welding, it is also known as oxy-fuel gas welding. Okay, now so in this process various fuels are mixed with the oxygen. Various fuel means different fuels can be used, but mostly acetylene used. Again I'm repeating, mostly acetylene is used. The reason is it can produce heat up to 3500 degrees centigrade. That is the reason. So whatever the fuel that we are going to mix with the oxygen, acetylene is the one which is capable of producing more amount of heat. That is the reason mostly C2H2, that is acetylene, is used in this one as a fuel. Other gases can also be used depending upon what material we are going to weld. But generally acetylene is used. So acetylene is used mixed with the oxygen and burned to perform the welding. Example is oxyacetylene welding, means C2H2 plus O2, and then heat will be produced. So we'll see oxyacetylene in our syllabus, it is there. So we'll see only oxyacetylene, that is C2H2, it is mixed with the oxygen. Okay, so it is performed, what happens, by flame formation, means once these two will be mixed and one it will be ignited, so there will be combustion and then flame will be formed. That flame will be inner will be there, outer will be there. We'll see, formed by the combustion of oxygen and acetylene. The flame comes from a torch. There will be a torch there where they will be mixing, and then so what happens actually, torch will be there where this, how much amount of acetylene will be there, C2 will be there, C2H2 will be there, and oxygen will be there. What will be their volume? What will be the volume of this one? What will be the volume of this one? That will be there in a torch. A particular torch will be there. Suppose this is the torch. So in this one, it's just like a carburetor, and then it will come out. Okay. So it's just like a carburetor. Here the mixture of the gases will be there. It's a kind of carburetor, just like in vehicle carburetors are there. Just like mixing chamber. So here acetylene and oxygen will be mixed properly, and then it will be ignited for the combustion. Okay. So what volume will be there? Different volumes may be there. Maybe acetylene is more, oxygen is less. Maybe both are same. Maybe oxygen is more, acetylene is less. Depending upon that, different flames are being generated, and those flames or the volume change that is used for welding of different materials. So what is the source here? Source is the exothermic reaction between the acetylene and the oxygen. Because of their combustion, what will happen, heat will be generated. That heat is used to weld the material. So we can see here, this is the base metal. What happens here, this is the torch. Torch means in this one there will be mixing of these two, acetylene and oxygen. So this mixture, once it will be mixed, it will come and burn here, and different flames will be generated. Externally, this filler rod is being used. So this pores will be deposited over there. This is our welding torch and this is the tip of the torch. Generally, a nozzle will be there at the tip. So through that nozzle, this flame or the combustion mixer will come out and it will burn, and in this area heat will be generated. Okay. So a filler rod coated with the flux is used sometimes, which prevents the oxygen and creating a better joint. Yeah, the rod which is used as a filler, it may be coated also. If it is a coated electrode, what will happen? This area it will be completely sealed from the outer oxygen. So in air, suppose I'm doing in a lab this experiment. So I know this weld pool, this area is completely open to the atmosphere. So what will happen? Oxygen, of course, will be there. So that will come and react with this area. Oxide will be formed. Oxide, we all know, will be a very brittle material. So overall property of the weld quality will be uh, reduced, or it will be not up to the mark. So what we have to do, if electrode we are using, the coat electrode can be also used. So this coating will come and after welding, and it will cover the whole area and it will shield the part where we have to do the welding. So what happens actually, what is the reaction? These two reactions are there. The C2H2 actually react with the oxygen, and what it forms? It forms CO2 plus H2O, and most importantly, it produces the heat. So two cores, these flames will be there. This is known as the outer and this is known as the inner. Temperature of these two will be completely different. So where this first reaction is happening, that is C2H2 oxygen reacting with the oxygen, so it's forming CO2 and it's forming H2O. Heat is produced, and this is at the inner core, this inner core, and its temperature is very high. Very high means approximately 3500 degrees centigrade. It's very high at the inner core. Another reaction occurs which is at the outer core. This outer core means this CO, carbon monoxide, it will react with the hydrogen and oxygen and it will form CO2, H2O, and it will also produce heat. That will be at this outer layer, and this outer layer temperature is generally less, and approximately it is 1260. So approximately the heat at this section will be 1300 degrees centigrade. So here it is relatively less, and here the temperature will be approximately 3500 degrees centigrade. Okay. The first stage reaction is seen in the inner core of the flame, and its color will also be different. So if you look at this inner core, its color will be bright white color, and the outer it will be almost colorless but with tinges of ranging from the blue to the orange. So from this also we can find out, and this is, as I said at the starting, different volumes of acetylene and oxygen will be. This is the general relation, general reaction which occurs. Okay, now what is the ratio? What is the ratio of the acetylene and what is the ratio of the oxygen over there in the torch? Depending upon that, three different flames are being generated, and accordingly, this inner core reaction will be same, but temperature will be different because of the different volumes of acetylene and because of the different volume of oxygen. So these three flames are being generated. If these two ratio, I mean the volume of acetylene and oxygen, if it is 1 is to 1, means both are in same quantity. This is known as neutral flame. You can see here, this is neutral flame. But if C2H2 is more and oxygen is less, it is known as of oxidized. Sorry, if O2 is more, means oxygen is more, and C2H2 is less, it is known as oxidizing flame. And if C2H2 is more and oxygen is less in volume or the quantity, it is known as reducing flame. So it may be reducing flame, it may be, this is neutral, and this is oxidizing flame. So depending upon what is the volume, what is the ratio, what is the quantity, these two have, that C2H2 and oxygen, three different flames will be generated, and accordingly the inner core temperature and outer core temperature will be different, and depending upon the material nature we'll use this different flame to weld the materials. So what is the advantage and what is the disadvantage of this process? The advantage of this process and disadvantage of the process one by one here. The combination of acetylene and oxygen is highly flammable. That is the disadvantage of this process. It's very difficult to store because it is flammable and hence hazardous to the atmosphere. That is the major drawback of this process. So how to store acetylene and how to store oxygen. Although it is generally stored in a separate cylinder having different color, but it is very dangerous if not properly controlled. It will be very dangerous for the environment. So it's, storing is very difficult. Another thing is unstable at pressures much lower than 1 atmosphere. Its unstability is the biggest issue if pressure is less than 1 atmosphere. So it's taking care or storing is the most dangerous part that we have to take care precisely or properly. Okay, it is mandatory for the welder to wear gloves, goggles, etc. Yeah, it's not like a shielded metal arc welding. Sorry, yeah, shielded metal arc where granules of flux were there, so you don't need to wear. Here, as you are using gases and there is reaction, so you know hazardous fumes will comes out. So you have to wear. Whoever is doing the welding, the welder or the technician, he should need to cover his hand, he need to cover his eyes, he need to cover completely. He should wear mask also so that whatever the dangerous gases or fumes are coming out during the welding, it shouldn't be inhaled by the welder because it will be very dangerous for his health, whoever is doing the welding. So these are the disadvantages of this process. What is the advantage? It is relatively cheap and portable. This is the most important thing. Portable, if it is portable, you can do welding at any place. Suppose you have to do in a remote area where it's very difficult to reach, and this setup is portable, so easily you can take from here to there, and there you can do the welding. So that these are the two very important parameters, and that makes it very important. Okay, so it is used as an economical, of course, versatile process that is well suited for low quantity. That is very production, low quantity or job repair. If in a small quantity you have to do, and where suppose some because of wear and tear some damage is there where you have to do the repairing, so this process is very useful in those cases. Another thing is it is rarely used to weld plates thicker than 6.5 mm. That is another drawback of this process. What is the drawback? That it there is restriction on the thickness of the plate that you can weld by this process. Just like resistance welding. In resistance welding, as I told, especially in a spot welding, you can weld only in lab configuration, and also there is a strict restriction on the thickness of the material that it can be welded by the process. Here also, this is the limitation of this process, that the material that you are going to weld thickness shouldn't be more than 6.5 mm. So generally, the welding is being performed on a thickness which is having value 6 less than 6.5 mm. Okay, so based on this one, we are going to take this numerical. We'll try to solve this one. It's a simple and easy numerical. What is there in this numerical? Nothing is there. So first we'll read and try to solve this numerical. Okay, so what is there in this numerical? An oxyacetylene torch supplies etna of acetylene. I mean 0.3 meter cube. This is the volume of acetylene per hour. Okay, and so what is the volume per hour? This has been given 0.3 meter cube. Okay, na? And an equal volume rate of oxygen for an oxyacetylene operation on 4.5 mm thick steel. Okay. Heat generated by combustion is transferred to the work surface with a transfer factor of F1 is equal to 0.20. If 75% of the heat from the flame is concentrated in a circular area on the work surface that is 9 mm in diameter, then find first one the rate of heat liberated during the combustion. So first, what will be the heat liberated? What will be the heat liberated? The heat liberated will be one value has not been given. Each transfer that HC value is not given. So that is actually 48,000, okay, no, kilojoule per hour. Okay, no. So what will be Q? Heat liberated. It will be simply volume is given into this HC. Total heat liberated. So what is the volume? It is 0.3 meter cube. So we can directly multiply 0.3 into 48,000. So what will be the value? Finally, it will comes out to 144. It will comes out 14400 kilowatt per hour. If we want this in kilojoule, not watt. If we want this in kilowatt, so we can convert it by dividing 3600. Directly I'm writing the value, so it will comes out 4.0 kilowatt. Kilowatt, yes, because we are dividing by 3600 now, so it will be kilowatt. So that is the first part that has been asked. Rate of heat liberated during the combustion. What is the second one? Rate of heat transfer to the work surface. Easy, this can be calculated because this coefficient is given in the problem. It is 0.20. So what will be heat transferred? This we can write 0.20 into 4. So how much it will be? It will be simply 0.8 kilowatt. Okay. What is the third one? Third one we have to calculate. What is this one? Average power density. Okay. So suppose this PD we have to calculate. So it will be simply, but it will be energy upon area. So what is the area? Area is equal to, we can calculate, it is a circular spot of 9 mm of diameter. So what it will be? Pi upon 4 d square. So it is in mm. So 9 into 10 to the minus square of this one. If we will calculate this one, so it will comes out directly. I'm writing the value 6.36 into 10 to the minus 5 meter square. So what we have to do? Sorry, this what will be this energy? So I'm writing here energy, because this transfer rate is given 75%. So we can calculate 0.75 into 0.8. So this will comes out 0.60. So now we can put this value here. So what it will be? PD, that is this average power density. PD will be simply 0.60 divided by this area 6.36 into 10 to the minus 5. Okay. Once you will calculate this one, so this value will comes out directly. I'm writing 9.43 kilowatt per centimeter square. So that is the A, B, and this is. It is quite easy. Nothing is there. All the things has been given. You just have to calculate the things. So that's all for the today's lecture. We'll stop here. We'll meet you again for another lecture with some other welding processes. Thank you.